Hello everyone. In this video I will be talking about the events that led to the proposition of Bohr's atomic model. One of the events was dual nature of light. In 17th century it was believed that light was made up of discrete particles which traveled in straight line, and it's very well known also that certain properties of light like reflection and diffraction could be explained on this property that light travels in straight line, but all of them cannot be. We will be talking about dual nature of light and focus on electromagnetic radiation. So dual nature of light says that light has both the properties of wave and of particle. So we will be talking about wave nature of light in this video. James Maxwell was the first person to suggest that when an charged body undergoes acceleration, it produces or it emits certain energy, and this energy has got both electric and magnetic field associated with it. Since the electric and magnetic field associated were perpendicular to the direction of propagation and also to each other, these type of radiations were called as electromagnetic radiation. That means radiation that has got both electric and magnetic field. I will draw a graph to show you that how the oscillations of electric and magnetic field are perpendicular to each other and also to the direction of propagation. Suppose if I have this, I have taken up this one. I'll take up the 3 axis. Let the x-axis be the direction of propagation, z-axis, and suppose this is the origin. Y-axis. Now these are the oscillations of electric field. The oscillations of magnetic field would be like something like this. Now if you cannot just visualize it how it can be, think in this manner. Suppose you have, this is the x-axis and you have got a wave on x-axis. This is the z and x-axis. Just rotate it by 90 degree. When you rotate it by 90 degree, you will have a wave on x and z plane. Similarly, you will have a wave on y and x plane. And both these waves will be perpendicular to each other and also to the direction of propagation. So I was talking about electromagnetic radiations. Electromagnetic radiations have certain properties. We will see what properties they have. We are going to see the characteristics of electromagnetic radiation. So we'll talk about characteristics of electromagnetic radiations. I have just written in short. So the first characteristic is that they do not require material medium for propagation like sound waves. So what does it mean? You know that sound waves cannot travel in vacuum, but electromagnetic radiations can travel in vacuum. And this is the reason why light from sun could reach to us, because there is no air in space. In space, there is no air, no material medium. So this shows that electromagnetic radiations can travel without any material medium, unlike sound waves. Second one, they travel with velocity. They travel with same velocity in vacuum, and which is equal to 3 into 10 to the power 8 meter per second, which is known as speed of light. Now these electromagnetic radiations, they consist of various radiations of different frequencies or wavelength. And when these frequencies and or wavelength are grouped together, we call them as electromagnetic spectrum. So electromagnetic spectrum has got wavelengths, different wavelengths or different frequencies. And what are these electromagnetic radiations of different types? Let us see that. When we talk about electromagnetic spectrum, you can say that it begins with gamma radiations, and gamma radiations are emitted from an unstable nucleus. When an unstable nucleus undergoes stability by emitting out radiation, and these radiations are neutral in nature, they do not have charge anything, but they are most energetic of all the electromagnetic radiations. And then we have X-rays. You already know about X-rays. After X-rays, we have got ultraviolet radiations, and ultraviolet radiations are also emitted from sun, and ultraviolet radiations are also used for sterilization of surgical equipments. And after ultraviolet radiations, we have wavelength ranging from 400 to 750 nanometer. And these radiations are known as visible light because only this part of the electromagnetic spectrum can be visible to us. Our eyes are sensitive to only this range of wavelength of electromagnetic radiation, and that is why they are known as visible light. And after visible light, we have infrared radiation. Infrared radiations have got heating effect. So whether the heat is coming out from an electric heater or you have got the heat from the sun, the heating effect is because of these infrared radiations. And after infrared radiations, we have microwave, and these microwaves are used in microwave ovens. And then we have radio waves. Radio waves are the least energetic of all, and they have largest wavelength. And because of least energy and large wavelength, they are used for telecommunications or for satellite communications. So visible light ranges from violet, that we call it vibrio, violet, indigo, blue, green, yellow, orange and red. And after red we have infrared, and before violet we have got ultraviolet radiations. So this is the entire electromagnetic spectrum, which consists of energy radiations of different frequency. The highest frequency is of gamma radiations, and these are the most energetic radiations, and they have got high penetrating power. Because of this property, gamma radiations are used for treatment of cancer cells. If we irradiate a cancerous part of the body with gamma radiations, they have got the capacity of killing them. So it is used in the treatment of cancer. X-rays, you already know, they cannot penetrate bones. They can penetrate the skin, but they cannot penetrate bones. Gamma radiation can penetrate even the bones. So we cannot click picture of bones using gamma radiations, but X-rays are blocked by bones. They can penetrate through flesh. So X-rays are used for taking the picture of bones and to find out the fractured part of the body. Ultraviolet radiations are still of less energy but are harmful. You know that ozone layer is important in the upper stratosphere, so that they are blocked and they are not able to reach the surface of the earth. Then we come to the visible part of the light, which consists of vibrio, infrared radiations, followed by microwave, and then radio wave. I repeat, microwaves are used in microwave ovens, radio waves are used in telecommunications, for radars also. So this is the entire electromagnetic spectrum. Now I will tell you about certain parameters on the basis of which we can study a wave. What are the parameters on the basis of which we study the properties of wave? So the first parameter is known as frequency. The first parameter is frequency, and it's represented by nu. You write it like this, the symbol is nu. And frequency is the number of waves passing through a point per second. Number of waves per second is known as frequency, and the SI unit of frequency is hertz. SI unit of frequency is hertz. Okay. So what is frequency? Frequency is the number of waves per second, and SI unit is hertz. The second parameter is wavelength. Wavelength is represented by the symbol called lambda. Lambda. And what is a wavelength? A wavelength is the distance between two crest and trough. I have drawn two waves over here. You can see these waves represent the displacement from the mean position. So this is the mean position of the wave, and this is the displacement from the mean position. So the upper part is known as crest, and the lower part, the maximum displacement, and the lower part is known as trough. So what is wavelength? The distance between two consecutive crests or two consecutive trough is known as wavelength. This is wavelength. The distance between two consecutive crests or two consecutive troughs are known as wavelength. So it's clear now. The third one is wave number. It is represented by nu and then a bar over it. And wave number is number of waves in per unit length. It is number of waves per unit length or distance, you can say, per unit distance. So its SI unit is meter per inverse. So wave number is also inverse of wavelength. So this is the formula you have to remember. Wave number is inverse of or reciprocal of wavelength. Now the next step we are going to do is now we consider another wave. This is a wave that I have considered. So this maximum displacement is known as amplitude. This is amplitude of wave. This is known as amplitude of wave. Now there is a formula, E is equal to H upon nu. This formula tells us the energy of an electromagnetic radiation. So nu is also equal to C upon lambda. So when we substitute it, it becomes E is equal to Hc upon lambda. So when you consider these two equations, higher the frequency, more is the energy of the radiation, and higher the wavelength, lesser will be the energy of the radiation. That means all the radiations with larger wavelength will have lesser energy associated with them, and those wavelengths that have got higher frequency will have more energy or will be highly energetic. So these two formula you already know. You'll have to do some numericals also. Now we will discuss about wave nature of light. wave nature of light. If we consider these waves and another wave, these are the two waves. So if they pass through a medium at the same time, then there are two conditions that will happen. When these waves interact with each other, let it be, I name it as wave A and wave B. If wave A and wave B interact with each other, when can they interact? If they pass through same point at the same moment through a medium, then the interaction will take place, or you can say the accident will take place. There are two possibilities. Either the crest of wave A overlaps with or superimposes with crest of wave B, or the other condition is that the crest overlaps with crest and trough with trough. This is one condition. Another condition is that crest overlaps with trough of another wave, and trough of one will overlap with crest of another. So in the first case, when crest overlaps with crest and trough with trough, such type of interference is known as constructive interference. And the resultant is that the amplitude of the resultant wave increases. So if both the interference will take place, then the resultant wave, we are talking about constructive interference. In constructive interference, the superpositioning of the two waves takes place in such a way that crest superimposes with crest and trough superimposes with trough. Then the amplitude of the resultant wave increases. The amplitude of the resultant wave increases, and this is known as constructive interference. But if the opposite will happen, it is known as destructive interference. In destructive interference, the amplitude of the resultant wave decreases. The amplitude of the resultant wave decreases because crest had superimposed with trough of the other, and this property is known as interference, and interference of wave cannot be explained on the basis of particle nature. It can only be explained when we consider light having the wave nature, when we consider that light also behaves like wave. So interference of wave proves that light has got dual nature, that means it also behaves like wave. Another property is diffraction. Now what is diffraction? Just consider. When light passes through a small opening or through a sharp edge, the bending of light through a sharp edge or sharp obstacle, or when it passes through a small opening or slit, is known as diffraction. So if we consider light as the wave, suppose it is coming out from far off places, it is behaving as waves. So this is the wave-like nature of light. So when we are coming closer, it's almost like straight line. So when it passes through a small opening, again the bending of light takes place through a small opening, and this is known as diffraction. Now this diffraction of light also shows that light behaves as a wave, and it not only behaves as a particle. So this discovery of dual nature of light prompted Bohr to think Rutherford's atomic model in a different way. So that's all for today, children, and in my next video I will be talking about atomic spectra.